Hello dear students, in this video I'll continue with revision on numbers quantification and numerical applications. Under this, the last topic is numerical inequalities. First we will see the questions from last year's term 1 board paper followed by the sample questions. So here the solution of x minus 3 by x plus 5 greater than 0, x not equal to minus 5, x belong to R is. So here we have to solve for x where x minus 3 by x plus 5 greater than 0. Here when we have questions of this type, we have to find the points on the number line where this function will be positive and negative. So let us find when x minus 3 is equal to 0, x is equal to 3, and when x plus 5 is equal to 0, x equal to minus 5. So we can divide this entire interval from minus infinity to infinity as minus infinity to minus 5, then minus 5 to 3, and then 3 to infinity. Here we need to solve for x where the inequality is given by x minus 3 by x plus 5 greater than 0. So here we have divided this entire number line into these three intervals. Starting from the right, we have the value for this function positive, then negative, then positive. Say for example, if we substitute any value in this interval, say 3 comma infinity. Say if we substitute 4. When we substitute x as 4, we will get 4 minus 3 by 4 plus 5. It is positive. And then if we consider this interval minus 5 to 3. Say if we take the point 0. 0 minus 3 by 0 plus 5, it is minus 3 by 5. So the value for this function x minus 3 by x plus 5, it is negative. And then when x takes values less than minus 5. Say for example, when x takes minus 6. Here we have minus 6 minus 3 by minus 6 plus 5. So it is minus 9 by minus 1, which is positive. So this function x minus 3 by x plus 5 is positive in this interval. So when we have inequations of this type, this is how we have to proceed. So here the values which x can take when this function is more than 0 is when x is more than 3 or when x is less than minus 5. So the correct option is option C, that is x less than minus 5 or x more than 3. Moving on to the next question, the solution of mod x plus 2 less than or equal to 5 is. So here if we have mod x less than or equal to a, then we have minus a less than or equal to x less than or equal to a. So this is how we will do if we have mod x less than or equal to a. Here we have mod x plus 2 less than or equal to 5. So if mod x plus 2 less than or equal to 5, then we have minus 5 less than or equal to x plus 2 less than or equal to 5. Now if we transpose this plus 2 to the other side, then we will have minus 5 minus 2 less than or equal to x plus less than or equal to x less than or equal to 5 minus 2. So minus 7 less than or equal to x less than or equal to 3. So here we have x belongs to closed minus 7 comma 3. So the correct option is option B. And now we have the questions from term 1 sample question paper last year's. For two distinct positive numbers x and y, we have to see which inequality will hold. When we have two distinct positive numbers, then their arithmetic mean is greater than geometric mean. So here the arithmetic mean of x and y is x plus y by 2 and the geometric mean is root of xy. So x plus y by 2 is greater than xy. From this we get x plus y greater than 2 root xy. So the correct option is option A. Next question, let p greater than 0 and q less than 0 and p comma q belong to z, that is p and q are integers. Then choose the correct inequality from the given below options to complete the statement. It is given p plus q dash p minus q. So in this dash we have to fill with one of these inequalities. So here we can see that p is a positive integer and q is a it is a negative integer. So we have to check which of these will come. Now here it is given q is less than 0. So if q is less than 0, then we have 2q, it is also less than 0. So if we have minus 2, it is less than 0. So minus 2 into 2, which is minus 4, it is also less than 0. So 2q is less than 0. As a result, we have q plus q is less than 0, or q is less than minus q. So from this we get q is less than minus q. Here we can see that p is a positive integer. So when we add p on both sides, then we have the same inequality. So p plus q is less than p minus q. So as a result, here we have p plus q and here we have p minus q. So the correct inequality is less than. So it is less than. So the correct option is option D. So p plus q is less than p minus q. Now we have some more questions on numerical inequalities. For any real number x, prove that 9 raised to x plus 9 raised to 1 minus x greater than or equal to 6. So here we can say that x is any real number. So we have this 9 raised to x and 9 raised to 1 minus x. If we consider these two numbers, then they are positive numbers. So if we have any two positive numbers, then their arithmetic mean, it is greater than or equal to geometric mean. So if we consider 9 raised to x and 9 raised to 1 minus x, which are greater than 0, then we have 9 raised to x plus 9 raised to 1 minus x by 2 greater than or equal to root of 9 raised to x into 9 raised to 1 minus x. Since arithmetic mean is greater than or equal to geometric mean. So from this we get 9 raised to x plus 9 raised to 1 minus x greater than or equal to 2 into, here we have root of 9 raised to x plus 1 minus x. So it is 9 raised to 1, which is 9. So from this we get 9 raised to x plus 9 raised to 1 minus x greater than or equal to 2 into root 9. Root 9 is 3. So 2 into 3 is 6. As a result, we have 9 raised to x plus 9 raised to 1 minus x. It is greater than or equal to 6. This is what we have to prove, and we have proved. Next question, if a, b, c are non-zero real numbers of the same sign, prove that a by b plus b by c plus c by a greater than or equal to 3. So here we can see that a, b and c are all non-zero real numbers of the same sign. So we can consider the numbers a by b, b by c and c by a as positive real numbers because they are of the same sign. If we have minus a by minus b, it becomes a by b. Similarly, if we have minus b by minus c, it will become b by c, and if we have minus c by minus a, it will become c by a. So we have, for positive numbers, a by b, b by c and c by a. Arithmetic mean greater than or equal to geometric mean. So arithmetic mean of these three is a by b plus b by c plus c by a. The whole thing by 3 is greater than or equal to the geometric mean. Geometric mean is cube root of a by b into b by c into c by a. So all these will get cancelled. We are left with cube root of 1, which is 1. So this whole thing is cube root of 1, it is equal to 1. So from this we have a by b plus b by c plus c by a is greater than or equal to 3. Now we have the next question, solve for x. 2 into 3 minus x greater than or equal to x by 5 plus 4. So let us represent this on the number line and then write the solution set. So from this we have 6 minus 2x is greater than or equal to, here if we take LCM we will get x plus 20 by 5. Let us cross multiply this so that we get 30 minus 10x greater than or equal to x plus 20. Now let us transpose this 20 to the other side and minus 10x to the right hand side. As a result, we get 30 minus 20 greater than or equal to x plus 10x. Or we have 10 greater than or equal to 11x. From this we get 11x less than or equal to 10, or x less than or equal to 10 by 11. So here if this is the number line, here we have minus infinity. Say suppose 10 by 11 is here. Here we have infinity. X less than or equal to 10 by 11. It is this part, this whole thing, including the point 10 by 11. So the solution set is open minus infinity, closed 10 by 11. So this is the solution set. Now moving on, next question. Insert the correct sign of inequality. Root 3 into root 50 minus root 32. Here we have to see what inequality will come. Here we have 3 into root of 54 minus 2 root 24. So when we have numbers with radical sign, it is better to square them and then we can compare the left hand side and the right hand side. So what we can do is, let us take x as the left hand side. Let x is equal to root of 3 into root 50 minus root 32 and y equal to 3 root 54 minus 2 root 24. Now let us find x square and y square. So x square will be root 3 the whole square becomes 3 into root 50 minus root 32 the whole square. So this is 3 into root 50 the whole square is 50 minus 2 into root of 50 into 32 plus root 32 the whole square is 32. So here we have 30 into 50 plus 32 is 82 minus 2 into this, let us factorize and write so that we can take the root. So 50 is 5 into 2 into 32 is, it is 2 into 2 5 times. So this is 3 into 82 minus 2 into root of 5 square into 2 raised to 6. So it becomes root 5 square is 5 and root 2 raised to 6 is 2 cube. So we have x square as 3 into 82 minus, here it is 80, 8 into 5 40 into 2 80. So this is 6. And now let us find y square. Y square equal to 3 root 54 minus 2 root 24 the whole square. So it is 3 root 54 the whole square, so it is 9 into 54, then minus 2 into 3 into 2 into root of 54 into 24 plus 4 into 24. So this is 486, 4 into 24 is 96 minus 12 into this root 54 into 24, it is 54 is 9 into 6 into 24 is 6 into 4. So this is root 9 is 3, root 6 square is 6, root 4 is 2. So it is 12 into 36. So this is 486 plus 96 minus 432. This when we simplify we get it as 150. So from this we can see that y square greater than or x square less than y square. X square less than y square implies x is less than y. So here we have taken x as root 3 into root 50 minus root 30, which is the left hand side. So this is less than this 3 root 54 minus 2 root 24. This implies root 3 into root 50 minus root 32 is less than 3 root 54 minus 2 root 24. So this is the correct sign of inequality. Next we have the next question. If a, b are positive real numbers, prove that 1 plus a square into 1 plus b square greater than or equal to 4ab. So here we can see that a and b are positive real numbers. So if we consider the positive real numbers, consider 1 and a square. So the arithmetic mean is greater than or equal to the geometric mean. So 1 plus a square by 2 is greater than or equal to root of 1 into a square, since arithmetic mean is greater than or equal to the geometric mean. So from this we get 1 plus a square greater than or equal to, here root square is a. If we transpose to the other side, we get 2a. Now let us consider 1 and b square. Again, these two are positive real numbers, so their arithmetic mean is greater than or equal to the geometric mean. So from this we get 1 plus b square greater than or equal to 2 into b. So let us take this inequality as 1 and this inequality as 2. In both these inequalities, since the left hand side are more than the right hand side, then the product of left hand side will be greater than the product of right hand side. So from 1 and 2, 1 plus a square into 1 plus b square is greater than or equal to 2a into 2b. Or we have 1 plus a square into 1 plus b square greater than or equal to 4ab. So this is what we have to prove, and we have proved. Now moving on, if a, b, c are positive real numbers, prove that a plus b the whole square greater than or equal to 4ab. Here there is no c, maybe there is. So here a plus b the whole square should be greater than or equal to 4ab. Since a and b are positive real numbers, we have a plus b by 2 greater than or equal to root ab. Since arithmetic mean greater than or equal to geometric mean. So from this we get a plus b greater than or equal to 2 root ab. Let us square both sides. So we will get a plus b the whole square greater than or equal to 4ab. So this is what we have to prove, and we have proved. Next question, if x is a positive real number, find the smallest value of x square plus 361 upon x. So here it is given x is a positive real number. We have to find the smallest value of this expression. Now x square plus 361 by x. It is equal to x square by x, which is x, plus 361 by x. So let us consider positive real numbers x and 361 by x. Now their arithmetic mean, it is greater than or equal to their geometric mean. Geometric mean is root of x into 361 by x. This is since arithmetic mean greater than or equal to geometric mean. So from this we get x plus 361 by x. It is greater than or equal to 2 into root 361. It is root 361 is 19. So it is 2 into 19. Or from this we get x square plus 361 the whole thing divided by x is greater than or equal to 38. So the value of this expression is greater than or equal to 38. As a result, the smallest value of this expression, it is 38. Therefore, the smallest value is 38. Now moving on to the next question. Solve for x 7 less than or equal to 3x plus 11 by 2 less than or equal to 11. When we have inequalities of such type, we can solve this inequality simultaneously both left hand side and right hand side, or if it is confusing, we can take the left hand side inequality separately, solve it, then the right hand side inequality separately, solve it, and then we can find the combined inequality. So let us solve it separately. So we have 7 less than or equal to 3x plus 11 divided by 2, and then we have 3x plus 11 by 2 less than or equal to 11. So if we transpose 2 to the other side, we get 14 less than or equal to 3x plus 11. Taking plus 11 to the other side, 14 minus 11 is 3. 3 less than or equal to 3x. Or we have, if we divide by 3, 1 less than or equal to x. From here we have 3x plus 11 less than or equal to 22. If we transpose 11 to the other side, we get 3x less than or equal to 22 minus 11, which is 11, and x less than or equal to 11 by 3. Now we can combine these two inequalities. From this we get 1 less than or equal to x less than or equal to 11 by 3. So the solution for x is x belongs to closed 1 comma 11 by 3. So this is the solution for x. Now we have some more questions. Next subdivision, 3 upon x minus 2 less than 1. Whenever we have a function of x in the denominator, it is important that we bring all the terms on the right hand side to one side and make the right hand side 0. So from this we will get 3 by x minus 2 minus 1 less than 0. If we take LCM, we will get 3 minus x plus 2 divided by x minus 2 less than 0. Or here we have 5 minus x upon x minus 2 less than 0. So here we have a linear function in x in the numerator and in the denominator. We have to see to it that the coefficient of x is positive in the numerator and the denominator. Otherwise, we can remove this negative sign and change the sign of inequality. So from this we will get x minus 5 upon x minus 2 is greater than 0. So if we remove the negative sign, it is minus of x minus 5 by x minus 2 less than 0. So if we multiply both sides by minus 1, we will get x minus 5 by x minus 2 greater than 0. So now we have the usual function of x in the numerator and in the denominator, and we have to find the values of x for which this function is more than 0. So let us find the points when x minus 5 equal to 0, x is 5, and x minus 2 equal to 0, x is 2. So if we take this as the number line, we have minus infinity to 2, then 2 to 5, and then 5 to infinity. Again, starting from right, we will have the value of this function more than 0. So here from 5 to infinity, it is positive. Say if we take any number 6 and check. So here if you put 6 minus 5 by 6 minus 2, it is positive. And then the sign will change after this. It is negative. Again it will change the next interval, it is positive. So if we consider this interval 2 to 5, if we check any point, say 3, then 3 minus 5 by 3 minus 2, it is minus 2 by 1, which is less than 0. So in this interval it is negative, and whereas in this interval from minus infinity to 2, it is again positive. So we need to have the intervals in which this function is more than 0, that is, it should be positive. So here we have x greater than 5 or x less than 2. So the solution set is minus infinity comma 2 open interval union open interval 5 comma infinity. So this is the solution set. Then we have the next question. 1 by x minus 1 greater than or equal to 2. So again, when we have a linear function in the denominator, we have to keep it as it is and make the right hand side 0. So from this we get 1 by x minus 1 minus 2 greater than or equal to 0. Let us take LCM. We will get 1 minus 2x plus 2 divided by x minus 1 greater than or equal to 0. Or we have 3 minus 2x by x minus 1 greater than or equal to 0. So when we have a linear function in x in the denominator, we have to keep it as it is and we have to proceed in this way. Now let us simplify this. Here, as I already mentioned, it is important that the coefficient of x should be positive both in the numerator and in the denominator. Here in the numerator, the coefficient of x is negative. So let us make it positive. So from this we get minus of 2x minus 3 upon x minus 1 greater than or equal to 0. So here minus of 2x minus 3 by x minus 1 greater than or equal to 0. If we multiply both sides by minus 1, then we will get 2x minus 3 by x minus 1 less than or equal to 0. Now, when 2x minus 3 equal to 0, we have x is equal to 3 by 2 and x minus 1 equal to 0, x equal to 1. So let us divide the number line into intervals minus infinity to 1, 1 to 3 by 2 and 3 by 2 to infinity. Again, starting from the right, the value of this function, it will be positive. So it will be alternatingly positive, negative, positive. We can check any values in this interval and confirm with this function. So here in the interval 3 by 2 to infinity, it is positive. In the interval 1 to 3 by 2, this function 2x minus 3 by x minus 1 is negative. And in the interval minus infinity to 1, it is positive. But we want the interval where it is negative, because 2x minus 3 by x minus 1 less than or equal to 0. So this function is less than or equal to 0 in this interval 1 to 3 by 2. So the solution set is 1 less than or equal to x less than or equal to 3 by 2, or x belongs to closed 1 comma 3 by 2. Now we have another question on modulus function. We have to solve for x when mod of 3x plus 2 greater than or equal to 5. Already we have seen a question where we had mod of x less than or equal to some number. So if we have mod x less than or equal to a, say, then we have minus a less than or equal to x less than or equal to a. On the other hand, if we have mod x greater than or equal to a, then we have x greater than or equal to a or x less than or equal to minus a. So this we have to remember. Here we have, in place of x we have 3x plus 2 and in place of a we have 5. So when we have mod of 3x plus 2 greater than or equal to 5, then we have 3x plus 2 greater than or equal to 5 or 3x plus 2 less than or equal to minus 5. So from this we can solve for x. So 3x greater than or equal to 5 minus 2, 3x greater than or equal to 3 or x greater than or equal to 1. And then here 3x less than or equal to minus 5 minus 2. So 3x less than or equal to minus 7, x less than or equal to minus 7 by 3. So we have x greater than or equal to 1 or x less than or equal to minus 7 by 3. So on the number line minus infinity to infinity, we have 1 here and minus 7 by 3 somewhere here. So x greater than or equal to 1 is this part and x less than or equal to minus 7 by 3 is this part. So we have x belongs to 1 comma infinity, closed 1 open infinity, union open minus infinity, closed minus 7 by 3. Therefore, the solution set is x belongs to open minus infinity, closed 7 by 3, union closed 1, open infinity. So this is the solution set. Next question, if a greater than 1, b greater than 1, then prove that log a to the base b plus log b to the base a greater than 2. So here it is given a is greater than 1 and b is greater than 1. So we have log a to the base b and log b to the base a are positive real numbers. So for positive real numbers, log a to the base b plus and log b to the base a. Arithmetic mean is greater than or equal to the geometric mean. So arithmetic mean of these two, it is log a to the base b plus log b to the base a by 2. This is greater than or equal to their geometric mean. Their geometric mean is root of their product. Log a to the base b into log b to the base a. Now we know that log b to the base a, it is 1 by log a to the base b. As a result, from this we get log a to the base b plus log b to the base a is greater than or equal to 2 into 1. Since it is 2 into log a to the base b into 1 by log a to the base b. Since log b to the base a equal to 1 by log a to the base b. This is by the properties of logarithm. So this is root 1, which is 1. So we have log a to the base b plus log b to the base a is greater than or equal to 2. So this is what we have to prove, and we have proved. So these are the various types of questions which I have taken from M.L. Agarwal book and R.D. Sharma book on numerical inequalities. I hope this video was useful for you. If you have not subscribed to my channel, please subscribe. If you find this video useful, share it with your friends. Thank you for watching.